Hello folks, I'm super happy to be with you today on DjangCon, and my name is Flávio Juvenal. I'm a partner at Vinta, and I'll talk with you about mixing reliability with Celery for delicious async tasks. I work at Vinta and we are a consultancy shop, web development, design and development shop from Brazil, and we've been building Django products for the last 10 years, and we've used a lot of Celery. And we've dealt with many Celery incidents, Celery issues, and I want to share with you what you can learn from our experience to really build reliable Celery projects. You can find the slides for this talk on this link and this QR code. Be sure to check that because there are lots of links here and lots of references. I'm assuming you already use Celery for this talk and you need reliability on your Celery project. If you are a Celery beginner and you need to learn Celery from scratch, you can check Tobias' talk. He'll do a deep dive into Celery and will reintroduce all the concepts. I won't do this here, but you can check his talk. In any case, if you are a beginner, please stay. I'm sure you learned something from Celery task loss risks and how the Celery infrastructure works in general. Okay, so Celery is our async tasks infrastructure, and we want to avoid lost tasks. We have to remember that Celery is a distributed system. We have the web process, we have the broker, and we have the worker processes. And there are task loss risks when those things communicate with each other to really execute, to really delay, queue, and execute tasks. There can be task loss between the web process and the broker. For example, a task can never be queued due to a broken connection. There is a connection between the web process and the broker, and this connection can fail. And if it fails, the task will be lost. You have to remember that when you do task delay, when you do my task delay, this operation can throw an operational error if the broker is down or unreachable. So the good news is that Celery will automatically retry task delays. It will retry 3 times, waiting 0.2 seconds between each try. But the task commit on the broker side can fail too. If the connection, even if the connection is fine, so even if everything is okay with the connection, the committing of the task on the broker side can fail. You can configure that on RabbitMQ. You can use the configuration confirm publish. So the delay will take a bit time more than the default, but then you'll be sure that after the task delay is done, the task is really on the broker side. So this is a default that is not clear that you have to perhaps change on Celery. Gigantic tasks can also bring down the worker. For example, if you pass large Python dicts as arguments, we have a real case at Vinta where we had 100 gigabytes of data inside RabbitMQ directories, data directories. And that happened because we were passing large amounts of XML data as task arguments, as task parameters. And instead, we should be passing data references, not data values. So we could use a blob storage like S3 and save the data there, and then send the URLs as parameters, as arguments for the tasks. So the tasks could download that and do the work. Or we could just use databases if we're dealing with relational data. But in any case, consider to use data references, not data values directly when passing data to tasks. It's worth remembering as well that lost tasks break user flows. So there's the classic, I didn't get the account verification email problem, right? The user just signed up and didn't get the account verification to finish, the account verification email to finish the sign up. So here we have a sign up view from Django, and we are doing the form valid. We are doing the form validation. After the form validation, we already have the response. We already saved the user. So on commit, I'll explain that better later, we are delaying a task to send the activation email. We are passing the user reference, the user PK, everything's all right here. But as we mentioned, the delay can fail. so this task can be lost. And there can happen a mismatch between the task state and the business logic. The database has committed the change, the user sign up is done, the user is saved on the database, but if the broker is down or if the connection with the broker fails, the verification email task is lost. So there's a failure of communication between the web process and the broker. Sometimes some applications just pass the button to the end user, click here to resend the email, who never did that and just click there. But is there a way for us to ensure an auto recovery? So if the broker is down, eventually the user can get the email. Is there a way we can build something to fix that for us automatically? There is a robust solution that we can implement. We can use the database as the source of truth, and we can source tasks from the database. To implement something like this, we need pooling. We need some way of checking the database from time to time, see if there are tasks that should run because the database state has changed. For example, a user is waiting for the account verification email. And if there is, we can queue tasks on the broker. So if the task infrastructure fails, you have to manually do consolidation work anyway, right? You have to write a script, send emails, things like that. Instead, you could have periodic tasks with Celery bit that queue other tasks that should run. So you can have this infrastructure where there is a task that will periodically check the database and queue other tasks. Here's the example of the verification email. We use Celery bit and we have a task, ensure verification emails, that iterates over users that have no verification email sent false. And for all those users, we are delaying the task send verification email task. We can keep the task send activation email on the sign up field. There's no problem in that. And we can rest assured that frequent periodic tasks, like every 5 minutes, will eventually queue the task, the send activation email task, if anything broke on the sign up view. So this way we have the best of both worlds. We still have the fast behavior during sign up of sending the email if everything is right, but we also have consolidation work to fix if that breaks. Okay, but imagine you want to build complex workflows, right? So you have a process day orders workflow where you want to fan out many process order calls in parallel to process many orders, like even millions of them. And then after all of those are done, you want to send them to logistics. You want to call a send to shipping task. So this task would have to wait all the orders to be done. You can also implement that with periodic tasks. But it's difficult to orchestrate a complex and long workflows or data-heavy pipelines with Celery and a database. Alternatively, you could use Celery Canva workflows, but I wouldn't recommend that. We've used that a lot on the last 10 years at Vinta, and we have many different issues. Here's a link that you can check later about, that's a blog post from another company that shares their findings about Celery Canva's workflows issues. You can check GitHub, Celery GitHub, and you'll find many issues related to Celery Canva's constructs like chords and stuff like that. So what I would recommend is better to not use Celery for workflow-focused problems. Instead, you should use workflow-focused tools. You have better monitoring, you have operability, you have error handling, you can run the tasks anywhere, like pods, containers, lambdas. It will be more integrated with the infrastructure. It won't be trivial to integrate with Django. It will be more like heavyweight. But I think if you have complex workflows, that's what you really need. The tools that I recommend for generic workflows are Prefect, Temporal, and Airflow. And for data-heavy pipelines, machine learning pipelines, data engineering pipelines, I would recommend you to check Dagster and Mage. Okay, so now let's talk about task loss between the broker and the worker. Remember the onCommit that I've shown? Now let's talk about this, why we need that. If you have atomic requests true in Django, and many projects have that, which means there is a transaction wrapping the whole view. If you do something like this, which is the naive way of delaying a task send activation email, you just like check the form valid, you get the user PK, and then you just delay the task. What can happen is that between the delaying of the task and the response, the task can execute in parallel to your view. And if that happens, you get this error. Does not exist, the user doesn't exist yet. Because the view didn't finish, so the transaction wasn't committed, but the task ran. So the user wasn't on the database yet. So you can lose tasks because of that, and you can have task errors, in fact. So the correct version is to only run this task after the database commits. So you use transaction on commit. Okay, so that's fine, that works, but you have also to consider that workers can shut down unexpectedly, and you have to decide a way to properly remove tasks from the broker. When it's safe, we have to figure out when it's safe to remove a task, to drop a task from the broker. Imagine you have the broker with the eat cake task, and the broker sends that task to the worker process. The worker process gets that task from the broker and says that it can handle it. Okay, so this task is not anymore on the broker, it's only on the worker. But this task, the eat cake task, can be lost if the worker fails. If there is not enough RAM on the worker, this task will just be lost. The task is not on the broker side anymore. And it's not on the worker side because the worker process has died due to out-of-memory errors. Workers can shut down unexpectedly. Sometimes it's so easy to forget that when we are using Celery. Nothing is 100% reliable, even if you take care to not have like memory errors, stuff like that. Even cloud containers will fail from time to time. Any kind of bad task code can also kill a worker. Any time of bad arguments, memory errors, stuff like that. You can have errors that you don't have any time to capture any exceptions, because, for example, the kernel might just kill the worker process if it's wasting too much memory. And finally, deploys can interrupt tasks. Sometimes, depending on the way you implemented the deployment process, the deployment script, it can just like kill the workers, and it will interrupt the running tasks. Okay, so when the eat cake task should be dropped from the broker? If it's right after the worker gets it, we have the situation that we just described, and that's the default. That's the default behavior of Celery. The broker drops the task right after the worker gets it. And that means task acts late false. That's the default. We can change that to only drop the task from the broker after the worker finishes. So if the worker fails, the broker will have to redeliver the task. The task will remain on the broker until the worker finishes, and if the worker fails, the task will be redelivered. That means task acts late true. You can activate that behavior, and you should activate that behavior. So you should activate that, and that means that the broker will wait for the worker's acknowledgement to drop the task. In the case of the worker process not having enough run and like losing the process being killed by the operating system, the task will remain on the broker side and it will be redelivered. Okay, but if tasks can be automatically redelivered, you need to ensure your task code is safely retriable. They need to be idempotent. Your code needs to be idempotent. It shouldn't matter that if the task is executed multiple times with the same arguments, there should be no side effects. That's what idempotency means. So you have to use ORM tools, ORM methods like get or create, update or create. You have to always be sure that you are like not redoing work unnecessarily, not doing side effects unnecessarily if you want to have your tasks to be idempotent. And also for making tasks idempotent, you may need atomicity. So you perhaps should wrap tasks in transaction atomic. So in any case they are interrupted, even due to a deploy or something like that, they will automatically roll back any DB changes, and eventually the broker will redeliver the tasks and it will be re-executed. But beware, you can have other side effects that are impossible to roll back, such as sending an email. So in this case, you can be smart and try to couple those impossible to roll back side effects with the DB state change and roll back if fail. So the database will tell you that you still have to send that email, similar to what we showed before with the activation email. And finally, you can just keep tasks short and fast to ensure they are easy and reliably retriable. Okay, but how does redelivery works? If the task stays on the broker, how it knows it needs to redeliver the task? On RabbitMQ, this is kind of automatic. You don't have to do anything about it. You just have to ensure that you have basically the default RabbitMQ configuration. That means you have a TCP connection and heartbeats between the broker and the worker. So if this connection is closed, RabbitMQ, your broker, will know that the worker has died and it needs to redeliver the tasks that this worker had got. On the case of other brokers like SQS and Redis, you don't have this connection, and you have something called visibility timeout. That means that if the task has not been acknowledged after n seconds, after a certain amount of seconds, it will be automatically redelivered. The default is 30 minutes for SQS and 1 hour for Redis. You can configure that with the visibility timeout on the broker transport options. There is a trade-off with the visibility timeout. After the visibility timeout, the task is automatically redelivered, even if the worker is still doing the tasks. Okay, so this is a problem because no task can take longer than the visibility timeout to finish, right? Otherwise, it will just be redelivered and the work will be repeated. If you increase the visibility timeout to give more time to your tasks, it will also take more time for tasks to be redelivered if worker fails. So you have a trade-off here, right? You are trading off fast redelivery versus long task support. So visibility timeout is not great in general. What's the solution for that? You can just use RabbitMQ as a broker. It doesn't need a visibility timeout as we discussed it. Or you shouldn't use Celery for workflows of long tasks, like we've discussed before as well. And you could also make task accelerate false, which is the default. It also means no visibility timeout, but it's not recommended because you avoid task redelivery, but you have task loss anyway for the reasons of task accelerate false. It's important to know that tasks are intentionally dropped on worker failure. That's a very surprising default, but it is what it is on Celery. By default, task reject worker loss setting is false. That means Celery will intentionally drop from the broker tasks that cause segmentation faults, out-of-memory errors, or SIG kills. So if your task is running and it receives a SIG kill, a lot of memory error, this task is automatically dropped from the broker. It won't be redelivered. If you change this to true, it will activate redelivery for all tasks, including the ones that can cause a worker process to die. So what Celery is trying to achieve here is to not have tasks that cause the worker to die to be redelivered, right? You can have a middle ground if you have tasks that sometimes fail, but sometimes they work. You can, on those tasks, you can change the task reject on worker loss setting, and you can keep the global default as it was before, false. It's important to remember that handling exceptions is also necessary. Task accelerate true only solves unexpected shutdowns like deploys. If a task raises an exception, it's still acknowledged. So if you have inside a task something like that, a cake objects get fantasy cake, and fantasy cake doesn't exist, it throws cake does not exist exception, the task is gone. The task won't be redelivered. Because of a default on Celery, that's actually a good default. That means task acts on failure or timeout, it's true. You can change that, but you shouldn't. Ideally, you should handle all possible exceptions in tasks. You should treat task exceptions, you should handle task exceptions with the same diligence that you handle 500 errors on Django views. If you want, if you have like intermittent errors, if you depend on external APIs, things like that, you should use retries. And there are many retries functionality. There is a great retry functionality in Celery. Just be careful with long retries because there is a catch that I'll mention later. Let's talk about deploys versus queued Celery tasks. When there are tasks in queue, be careful with deployments. If you change the task signature, the function parameters, the new worker processes after deployment won't be able to deal with what's already queued with the older parameters. So the parameters have changed, so the task has changed, but the new workers won't be able to deal with the task. Imagine you had a task cake with cake ID, but you changed to dessert ID and it's structured differently. The new workers won't be able to deal with the old tasks that were queued and are being redelivered. So be careful with that. There will be very cryptic, and you need to ensure that the queues are empty if you are changing task signatures. Be careful as well when you are upgrading Celery, because the internal task payloads can change. The errors will be very cryptic as well. And ETA tasks are also a problem here because they live on the worker memory. Yes, that's very surprising. I won't have much time to talk about that, but in general, you don't want ETA countdown tasks because they live on worker memory waiting for the time to run. And they be equivalent of queue tasks, and the task signature can change, the payload can change, and they are very complex to deal with. So in general, you should avoid any ETA or countdown tasks that are more than few seconds. About running Celery tasks when you are doing deploys, be careful with that because you have to decide what you are going to do about the old Celery workers if you are refreshing the Seva. Are you doing a seek term or are you doing a seek queue with the worker processes? If you're doing a seek queue, the task reject on worker loss behavior that we talked about might bite you because Celery will think that you want to interrupt the task and never retry and never redeliver it again. So check what's happening with your old processes. Double check if the redelivery is working. Double check if these processes are really gone from your machine after you do the deploys. There are other reliability concerns that I won't have much time to talk about, but please check those links. They are really important. The ETA tasks that I've quickly mentioned, they shouldn't be on the far future. They should be only a few seconds after. The same is valid for retries because retries are ETA tasks behind the scenes. You can route priority tasks to dedicated queues and workers. That's very important, to have different task latencies and stuff like that. You can prevent clogged queues with task time limits. If you have badly behaved requests that take a long time, you should have timeouts and time limits for those sort of things. You can expire tasks that shouldn't run after a due date time. It's very frustrating for a user to get notifications saying that something will happen in 2 minutes, but that something happened a day ago. So you should expire those types of tasks. You should set up alerts, monitoring, tracing, observability on Celery. Please check those tools. You can set up dead letter queues as well if you want. Check those links. There's lots of information there. I've prepared a gist with all the recommended Celery settings for reliability that I've discussed on this talk and other settings as well. Please check it. It will surely be awesome for you, and it's all documented there. Please comment there as well if you have other settings that you are using for increased reliability on Celery. And that's it. Please feel free to reach me if you have any questions. Here's my Linktree. Here's my Twitter. And if you need Celery consultancy, please feel free to reach Vinta. Please feel free to reach me directly or reach Vinta. We will be super happy to work with you with your Celery project. Thank you very much.